So you've made it to the very last unit of college algebra. A few more sections and you're done. All right, let's do this. Let's hustle. All right, so this unit is on library of functions and then matrices. All right, the library of functions is just all the different kind of functions that we've studied, and I just kind of wrap it all up together. I'm going to focus on the 7 main ones. But these are all the ones we've learned in this course. Okay, and I'm going to remind you and reiterate how they transform. So this is the transformation of those functions. All right, so there's the constant function, which is like y equals 5, y equals -9. Then there is the identity function, or also called linear function, which is y equals x. Y'all know it as y equals mx plus b. There's the, okay, and this one is a diagonal line. There's the absolute value function. Think of it as like the v in value. That's the shape it makes. There's the quadratic function. We did a lot with quadratics. It makes a u, like the u in quadratic. It's called a parabola. There's the square root function. Think of it like this is the letter r, and this is the top piece of the r right there, the function. There's the cubic function, x cubed, and I don't have any cute thing. It's just like a windy road type or river. The cubed root is the cubic function, just turned because they're inverses. All right, and then we have the other ones. So we did rational. Rational is 1 divided by x. So I went to y equals and I typed 1 divided by x. And then I graph it, and that's what he looks like. So rational is this guy. Okay. 1 divided by x squared is this guy. Get a different color. Okay, exponential is like 2 to the x, 3 to the x, 4 to the x. It looks like this. He starts off at 1. All right, that's exponential. Base e would be e to the x. Same thing. Not 1, e to the x. Log is at 1. Natural log. There's errors on all these guys. Here too. Natural log, same thing as here. Let me show you how to type them in. So y equals, you push log x, and then graph, and it goes through 1, 0. Natural log, and then push ln x, and then graph, same thing, 1, 0. All right, and then piecewise function is there's no real like parent function. It is pieces of various functions. All right, and so these are all the ones, like this basically what college algebra is about, all these different kind of functions that exist. Okay, and they all move the exact same way. If there is a number in front, if it's negative, okay, it reflects on the x-axis if it's negative. And this is wrong. If it's a fraction between 0 and 1, it gets wider, so it stretches. If it's between 0 and 1. If it's greater than 1, then it gets skinnier. It shrinks. Like if it was 5 versus 1/2. If this right here, if it's negative, it reflects on the y-axis. There's a number with the x, then it's a horizontal shift. And it's opposite of what you think because of this negative sign right there. So if it's a positive number, it moves left. If it's a negative number, it moves right. And this doesn't matter. Cubic function, log function, exponential function, absolute value, quadratic, linear, like it all the same. It all moves the exact same way. It does not matter the function. And then you have the constant over here, and that's the vertical shift. And it moves up if it's positive, down if it's negative. And so this sometimes also sometimes there's like an x squared right here or x cubed or something. But they all move the same way, right? And so this is a good graphic organizer. All right, so let's just look at this random function right here. Okay, this guy, let's get a pretty guy. I like that. That was fun. This guy says he's going to move down 1. So everywhere these guys are, I'm just going to move everything down 1. So that's my new function. That's it. So it doesn't matter the function. Do another one. Here, it's inside with the x. And so I think it's going to move right, but it's opposite. So it's going to go left 1. So everything moves left 1. So it just shifts everything left 1 from the original guy. It just shifts everything over left 1. Here, this right here makes it reflect on the x-axis. So instead of it being up here, it's going to be down here. And let's try a different function. This, with the negative with the x, it's going to reflect on the y-axis. So everything will be opposite. Right, so now this is what the function looks like. That guy. Right here, this means it's going to go up 3, not left 2 like we think, it's going to go right 2. So from every point, we're going to go up 3, right 2. 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 So that's our new function. Okay. So here, now let's do our parent functions. Man, no more. Right, so the parent function is just the original guy. X squared is a parabola. We're just sketching by hand, so I don't need it perfection. Right, then this right here, he is going to go up 6. So 6, and then still a parabola. Should have made it equally as wide, but that's okay. That's it. All right, here, the parent function is like this, forever. And then this guy, it's not going to move left like we think, he'll move right 4. This is 4. And then make a U, not a V. And so that's how it moves. The red is your answer. The black is the parent function. Right here, the original guy is like this. And then this is going to reflect on the x-axis. So he's going to turn down. Turn down for what? I'm just kidding. For the x-axis, obviously. Okay. Such a dork. Okay. All right, now we're at cubed. So this is the normal guy for cubed. And hey, don't stress. Oh my god, I can't remember what these fractions are. No worries. Cubed. In your calculator, go to y equals, okay? Type x up 3. And the x button is right here. X up 3, and then graph. All right, there you go. Cube function. All right, and so this guy, he's going to move down 3 because of that. And then he's going to go, not right, he's going to go left 2. 2. All right. 1, 2, 3, left 2. So right here is our new point. So the red is how he transformed, how he moved. Right here, our normal guy, like that, close enough. It's just by hand. All right, we need to go down 2 because of him, and here we need to go left 3. Look at something real quick. Okay. And so here we go down 2, left 1, 2, 3. This is like our new vertex, our new starting point. Go. All right, our normal guy looks like this. And then he, because it's inside with the x, is going to reflect on the y-axis. He's going to go like that. I'm going to stop this video, and on the next video, I'll pick up where I left off. I'll pick up right here.